understanding those nuances of how well it's doing.
Exactly. And we'll also talk about overfitting. That's when the classifier learns the training data too well and doesn't do so well on new data.
It's like memorizing the answers for a test instead of actually understanding the material.
Exactly. We want classifiers that can handle new examples, not just repeat what they've already seen. Now think about something like spam filtering. That's a classic text categorization problem.
Right, so the classifier is trained on a bunch of emails that are already labeled as spam or not spam.
Right. So you're showing the classifier examples of good and bad emails.
And then when a new email comes in, the classifier uses that model to predict whether it's spam or not.
Exactly. And it's amazing how much of our digital lives are shaped by these algorithms.
It really is. And with the amount of text data growing all the time, these techniques are just going to become more and more important. Now, Chapter 17 takes us into this fascinating world of figuring out what words actually mean. Probabilistic models of word meaning. It's like we're moving beyond just recognizing words to really understanding them.
That's it. This chapter is all about representing the meaning of words using statistical models.
I remember from earlier chapters that words can have multiple meanings. So how do we teach a computer to tell the difference between those different meanings?
One approach is called distributional semantics. It's based on the idea that a word's meaning is reflected in the words it hangs out with.
Like that saying, you are who you hang out with. If a word tends to appear near certain other words, that tells us something about its meaning.
Exactly. And we can capture those relationships using co-occurrence matrices. They track how often words appear together.
So if bank often appears near money, deposit, and loan, that suggests it has something to do with finance.
Precisely. And we can use more sophisticated techniques like latent semantic analysis, LSA. We talked about that earlier with information retrieval.
Right. LSA helps us find those hidden relationships between words based on how often they appear together in a large amount of text.
Exactly. Another powerful approach is using vector space models. We represent words as vectors in this multidimensional space.
Vectors, like those arrows we learned about in physics.
Yes. But in this case, those arrows represent words. The direction and length of the arrow tells us something about the meaning of that word.
So words with similar meanings would be represented by vectors that are close together in this space.
Exactly. And words with totally different meanings would have vectors that are far apart.
So it's like we're creating this map of meaning. We can see how words relate to each other based on how close or far apart their meanings are.
Right. And we can use these vector space models for lots of different NLP tasks. Finding synonyms, identifying semantic relationships between words, even figuring out how similar two sentences or documents are in terms of meaning.
It's like we're giving computers this amazing ability to understand those nuances of human language.
It's a powerful tool, but we have to remember it's still based on statistical analysis. We're capturing patterns and probabilities, but we're not perfectly replicating the way humans understand meaning.
Right. There are still challenges when it comes to those multiple meanings, connotations, and all those subtle shades of meaning.
Absolutely. But these probabilistic models of word meaning have been incredibly successful, and researchers are constantly working on making them even better.
Now, Chapter 18 takes a step back and looks at the big picture. Statistical NLP as a whole.
It's a bit of a meta chapter, right? It looks at those broader themes, the challenges, and the implications of this whole statistical approach to language.
So a time for reflection, to assess where we've been and where we're going.
Exactly. And one big theme they talk about is evaluation. How do we know if our models are actually working? How do we compare different approaches?
Right. It's easy to get caught up in all those technical details. But we have to make sure those models are actually solving the problems we're interested in.
And another important theme is generalization. Can our models handle new examples, things they haven't seen before? Can they adapt to different types of text?
We don't want our models to fall apart if they encounter something slightly different. They need to be flexible.
Exactly. We need robust models that can handle real-world language, which is messy and unpredictable.
And they also discuss the role of linguistics in statistical NLP. How can we bridge the gap between those formal theories of language and these statistical models?
It's a two-way street, really. We can use statistical methods to test and refine our linguistic theories, and we can use linguistic insights to build better statistical models.
So it's like a collaboration. Each field benefits from the other.
Exactly. And the interdisciplinary approach is crucial if we want to understand how language really works. Of course, they also acknowledge the limitations of the statistical approach. Language isn't just probabilities and patterns, right? There are rules and constraints and all sorts of subtleties that our models might miss.
Right. Statistics is a powerful tool, but it's not a magic wand. We need to know what it can and can't do, and be open to other approaches, too.
Exactly. It's like having a whole toolbox. You need to know which tool to use for each job.
Okay, now, Chapter 19 takes us on a little trip back in time, exploring the early days of statistical NLP.
A history lesson. I always love learning about how ideas develop and how fields evolve.
It's a fascinating story. It highlights those pioneers who paved the way for the field as we know it today.
So where does this story begin? Well, one key figure is Warren Weaver. Back in 1949, he proposed using statistical methods to understand language. He was inspired by how successful they were in breaking enemy codes during World War II.
Wow. It's amazing to think how those wartime innovations led to breakthroughs in language processing.
And then there were researchers like Yehoshua Bar Hillel. He developed some of the first machine translation systems, and there was the Ale Pack report. That one actually dampened enthusiasm for machine translation for a while.
So there were bumps in the road, setbacks along the way.
Definitely. But those early efforts were crucial. They laid the groundwork for the resurgence of statistical NLP in the 1980s, fueled by those large corporas that became available and those more powerful computers.
It's like the field was waiting for the right moment, the right combination of data and computing power to really take off.
Exactly. And those early successes in things like part-of-speech tagging and parsing really paved the way for the huge amount of research we see today.
And speaking of the future, Chapter 20 is all about looking ahead, trying to predict where statistical NLP is going.
It's a chapter full of exciting possibilities and tough challenges, thinking about what the next big breakthroughs might be and what obstacles are still in our way.
So what are some of the key areas they highlight for future research?
One area is moving beyond those bag of words models. Those models treat words as independent units. But we need to capture the real syntax and semantics of language, how words connect and create meaning.
Right. It's more than just recognizing words. It's about understanding how they relate to each other in a sentence and what they contribute to the overall meaning.
Exactly. Another challenge is developing models that are more robust and adaptive, ones that can handle all those complexities of real-world language.
We've talked a lot about how messy and unpredictable language can be. Our models need to be able to deal with that.
Right. And we also need better ways to evaluate and compare all the different NLP systems out there.
Because with so many options to choose from, we need to be able to figure out which approach is best for each specific task.
Absolutely. And another important aspect is collaboration between different fields.
Right. We've seen how statistical NLP draws on ideas from linguistics, computer science, psychology, and other fields.
And as the field keeps growing, those collaborations are going to be even more important, especially if we want to tackle those big challenges.
Okay, on to Chapter 21. It sounds like we're going to see those statistical NLP techniques in action, solving real problems.
You got it. This chapter is all about applying statistical NLP in different domains, seeing how these techniques can be used to make a real difference.
So it's like taking those abstract concepts and seeing how they work in the real world.
Exactly. One key application is information extraction, pulling out specific bits of information from text.
I remember we touched on that before. It's like teaching computers to read between the lines and find those nuggets of knowledge buried in all that text.
Right. And we can use statistical NLP to identify things like names of people, places, and organizations, or to figure out the key events in a news story.
So it's like having a computer assistant that reads tons of documents and summarizes the important stuff for you.
Exactly. And another application is question answering, building systems that can answer questions you ask in natural language.
That sounds straight out of science fiction. Asking a computer a question and getting a real answer.
I know, right? But it's becoming more and more real thanks to advances in statistical NLP. These systems can search through tons of information to find the most relevant and accurate answers.
It's like having a digital librarian right at your fingertips.
And then there's text summarization, creating those short, informative summaries of longer documents.
That would be a lifesaver for anyone who has to read through a lot of long documents. Students, researchers, you name it.
Absolutely. Statistical NLP can help identify the key points and condense them into something much shorter and easier to digest.
Like a super efficient note taker who can get to the heart of the matter without all the extra stuff.
Exactly. And another cool application is dialogue systems. building those conversational agents that can interact with us in natural language.
Like those chatbots we see popping up everywhere. But these dialogue systems are much more advanced, right?
Yeah. Oh, much more. The goal is to create systems that understand what we mean, respond appropriately, and actually hold a conversation.
It's like we're getting closer and closer to that science fiction idea of intelligent machines that can talk to us and understand us.
It's pretty exciting. And of course, we can't forget about machine translation. We talked about that earlier. Statistical NLP has completely changed the game, making it possible to translate text between languages with amazing accuracy and fluency.
It's like we're building those universal translators we've seen in movies, breaking down language barriers and helping people from different cultures understand each other better.
It's a powerful vision, and these are just a few examples of what statistical NLP can do. It's a field that's constantly growing and finding new ways to use the power of language to solve those real-world problems.
Okay, it feels like we're approaching the grand finale of our deep dive.
Chapter 22 brings our journey through foundations of statistical NLP to a close. It offers some final thoughts on where the field is and where it might be headed.
So it's like taking a moment to appreciate how far we've come and to imagine what might be next.
Exactly. And while the authors acknowledge all the incredible progress we've made, they also point out that there's still a lot we don't know about language.
Like we've explored the tip of the iceberg, but there's this whole vast world beneath the surface.
And they highlight some key areas for future research, like developing better models of language that capture all those subtle nuances of meaning and context, finding ways to handle real-world language, and building more robust and reliable systems that we can use in real applications.
So we're constantly pushing the boundaries, trying to create systems that can truly understand and process language the way we do.
Exactly. And they also talk about the importance of ethics, making sure we use these powerful technologies responsibly for the benefit of humanity.
Right. As we develop these increasingly sophisticated tools, we need to think about their impact on society and make sure they align with our values.
Absolutely. And they encourage us to stay curious, keep exploring those mysteries of language, and push the limits of what we can do with statistical NLP.
It's like we're on this endless quest for knowledge, using these powerful tools to unlock the secrets of language.
Exactly. And who knows what incredible discoveries are waiting for us down the road.
Okay, chapter 23 brings us back to information retrieval. But this time, we're zeroing in on the web.
It's like taking everything we learned about IR in Chapter 15 and applying it to the massive, ever-changing world of the internet.
Right. We discussed the challenges of dealing with a huge amount of data, the different formats, the problem of spam. But now we're going to see how those challenges are tackled in the context of web search.
Exactly. And one of the key differences here is the importance of link analysis. Remember, we talked about that earlier.
Right. It's about using those hyperlinks to figure out which pages are important and trustworthy.
Exactly. And there are a bunch of different algorithms for doing link analysis, each with its own strengths and weaknesses.
So it's not just about counting links, it's about understanding what those links tell us about the page.
You got it. And these algorithms are essential for fighting spam and making sure that people get those relevant, reliable results when they search online.
Okay, now on to chapter 24. This one sounds like it could be really insightful.
This chapter is all about text mining, using statistical NLP to dig deep into those mountains of text data and uncover knowledge and insights.
It's like panning for gold, sifting through all those words and sentences to find those nuggets of valuable information.
Exactly. And we're going beyond just finding answers to specific questions, like in question answering. Text mining is about discovering patterns, trends, and relationships that might not be obvious just from reading the text.
It's about finding those hidden connections that might surprise you, those aha moments that make you see things in a new way.
And this can be applied to so many areas. Market research, business intelligence, scientific discovery, even social science research. It's not just for tech companies and data scientists. It's for anyone who wants to understand large amounts of text data.
Exactly. And we'll look at some of the key techniques they use in text mining, things like clustering and classification, topic modeling, and sentiment analysis.
It's like taking all the tools we've learned about throughout this book and using them to explore this new frontier.
But they also emphasize that text mining isn't just about crunching numbers and running algorithms.
You're right. It's about combining those computational techniques with human expertise, domain knowledge, and critical thinking.
Because in the end, it's not the patterns themselves that are valuable. It's the insights we gain from those patterns and how we use them to make better decisions, understand the world around us, and come up with new ideas.
Text mining is a powerful tool, but it's important to use it wisely and ethically. And with that, we've reached the end of our deep dive into foundations of statistical NLP. What an incredible journey. We started with those basic concepts of probability and ended up exploring cutting-edge techniques like text mining. It's been quite a ride.
It really has. We've seen how statistical NLP is changing how we interact with language. From searching for information to translating languages to extracting knowledge from text, it's amazing.
And as the amount of text data keeps growing, statistical NLP is going to become even more important.
This book has given us a glimpse into the power of this field, but it really is just the beginning.
There's so much more to discover, and statistical NLP is giving us the tools to do just that.
So if you're curious about language, about data, about how computers are learning to understand the world, I really encourage you to explore this fascinating field.
You never know. You might be the one who makes the next big breakthrough.
And on that note, we'll wrap up this episode of The Deep Dive. Thanks for joining us. We'll see you next time for another adventure in the world of knowledge. Welcome back to The Deep Dive.
We're in the home stretch now of our exploration of foundations of statistical NLP.
We've been on quite a journey, haven't we? Through those core concepts, the history of the field. We even took a peek into the future.
And now, as we wrap things up with these last couple chapters, we're going to see how statistical NLP is tackling some real-world problems.
Chapter 23 takes us back to the intersection of information retrieval and the web. Remember, we touched on this earlier. But now we're really diving deep into how search engines work their magic.
It's like peeking behind the curtain of those search boxes we use every day, trying to understand that complex machinery that delivers those results.
It's mind-blowing when you think about how massive the web is and all the challenges involved in finding what you're looking for amidst all that noise.
Right. The authors do a great job of highlighting those unique challenges. The sheer volume of data, the content that's constantly changing, the need to deal with all sorts of formats and languages, and of course the never-ending battle against spam.
We talked about link analysis earlier, and it seems like that plays a huge role in fighting spam and figuring out how relevant search results are.
Absolutely. Link analysis takes advantage of how interconnected the web is, using those links between pages as clues about which ones are authoritative and trustworthy.
It's like those pages are voting for each other, right? And the ones that get the most votes from those reputable sources, those are the ones that rise to the top.
That's a great way to think about it. And the authors go into some of those key link analysis algorithms, like PageRank, which, as we mentioned, is one of the secrets behind Google's success.
It really is incredible when you think about it. This idea of analyzing links has had such a huge impact on how we find information online.
It just shows the power of statistical NLP to find order and meaning in all that data. Okay, ready for chapter 24. This one I've been looking forward to. Text mining. It sounds so powerful, like we're using language to understand the world around us.
This chapter really showcases how we can use statistical NLP to go beyond those basic tasks like information retrieval and machine translation.
It's about extracting knowledge and insights from all that unstructured text data, uncovering those hidden patterns and connections that might not be obvious at first glance.
And the applications are all over the place. Market research, business intelligence, scientific discovery, you name it.
Exactly. It's not just about analyzing words. It's about using language to understand human behavior, social trends, even the natural world.
So many possibilities. Imagine analyzing customer reviews to see what people like and dislike about a product, or tracking social media to gauge public opinion on something.
Or maybe mining those scientific articles to discover new links between genes and diseases. Or analyzing historical texts to understand how society has changed over time. It's incredible.
It really is. And the authors take us through some of those key techniques used in text mining. We see those familiar tools like clustering and classification, and then some more advanced techniques like topic modeling and sentiment analysis.
It's like we've been building up our statistical NLP toolkit throughout this book. And now we're putting those tools to work in this new and exciting area.
They also make a good point about the importance of human expertise in text mining. It's not just about letting the algorithms run wild.
Right. You have to combine those computational techniques with domain knowledge and critical thinking to make sense of what you find.
Because ultimately, it's not just about finding patterns. It's about understanding what those patterns mean and how we can use them to make better decisions, understand the world around us, and come up with new ideas.
Text mining is a powerful tool, but it's up to us to use it responsibly.
And with that, we've reached the end of our deep dive into foundations of statistical NLP. What an amazing journey it's been.
It really has. We covered so much ground, from those basic building blocks of probability all the way to those cutting-edge techniques in text mining. It's been quite a ride.
We've seen how statistical NLP is changing the way we use language, how we find information, how we translate between languages, how we extract knowledge from text. It's transforming so many aspects of our lives.
And with all that text data out there, the future of this field is incredibly exciting.
This book has given us a taste of what's possible, but it's just the beginning. There's so much more to discover.
And who knows? Maybe you'll be the one to make those next big breakthroughs.
If you're fascinated by language, by data, by how computers are learning to understand the world, I encourage you to dive in. Explore this incredible field.
The possibilities are endless.
And on that note, we'll wrap up this episode of The Deep Dive. Thanks for joining us on this amazing journey. We'll see you next time for another adventure in the world of knowledge.